All right, good morning. I wanted to take a little bit of time just to review what a differential equation is and some of the types of questions and you can be expected to solve the national exam. So it's a common concept. Differential equation you can think of as something that has a dy over a dx, and then usually at some point they're going to ask you to find a particular solution, which means you solve this or solve the differential equation. And you're usually solving for whatever variable is right there. You're working backwards. You're finding y, you're taking an antiderivative. All these things mean the same. Sometimes these questions involve slope fields. Sometimes they involve Euler's method. Sometimes they involve logistics, meaning that the differential equation that you solve will have a partial fraction in it. But most of them always involve finding the particular solution. And with the test kind of weird this year, I would expect that that's the part you're going to be asked to do. These two pieces are actually BC topics. So if you're in the AB, take an AB test, don't even worry about it. Okay, I am going to just talk about part A and C though, just in case something does come up. And so part A says the axis provided sketch a slope field. So slope is by definition dy dx. And so the slope field is just a bunch of little slopes at different points. So for instance, if you want to sketch the slope at the point 1, 0, you would take your dy dx equation and plug in 0 for y and 1 for x, and you would get -1. And so you put a little line that has a -1 slope. If you're going to do it at the next point up at 1, 1, you'd have a 1 minus 1 over a 1 squared. You have a horizontal line. And sometimes, if you realize that anytime y is 1, the numerator is going to be 0, and so you'd actually have a bunch of horizontal lines. So that's kind of a strategy to do it quickly if you can look for those. I'll do one more point, but you can see that this kind of eats up time, and time is at a premium this year's exam. So I don't think you're going to be asked to sketch a slope field, but doesn't mean you can't know how to do it. So if I do maybe this point, -1, 0, you'd have 0 minus 1 over -1 squared. Looks like it would still be a -1. So for fun, you could fill in the extra ones if you want to. All right, the second question, or part B, I should say, I think is where we want to focus our time. So find the particular solution of y equals f of x to the differential equation with the initial condition that's usually given. And the translation for that is that's going to help you find your c value. Because remember, when you take an antiderivative, it's going to have a c in it. So this is going to help us find c. And that's something that will probably show up in some form or another. So for part B, I'm going to start with my dy dx, which is y minus 1 over x squared. And the first step and step you need to know 100% is to separate the variables. So I'm going to move the y to the left, and I'm going to move the dx to the right. And just be careful with your fractions and all that stuff, because you got a lot going on here. After you move the variables, you're always going to integrate both sides, and that's why you move them, because you have to have x's with dx's and so forth. And this is going to be ln of y minus 1, and this is going to be -x to the -1. I'm using the power rule, skipping some steps. So you can go back and check that if you need to. And then there are just a couple c's, and you can combine the c's, so there's some shortcuts I'm using. But I'm going to try to isolate y, because that's my goal here. So if I apply an e to both sides, I would have y minus 1. And then technically here, I have e to the -x plus c. But we talked about how e to the c is some other c value. And some of you prefer to use subscripts. Sometimes there's a new variable like k or something introduced in here. But you don't have to use the subscripts or the k. But the idea is that we could rewrite this as c e to the -1x. And then if I isolate y, I'd have like a 1 plus CE to the negative 1x. So this usually is called the general solution, and sometimes that's asked for. You probably get some points if you take it this far, but when you have a particular value here, the idea is you want to actually find that C value by using the point that's given. So it's given in function notation, but it means that point. So let me slide up here a little bit. So if I substitute 0 in for y, and I plug in, what would that be? Negative 1 over 2. If I solve for C, I would have negative 1 divided by e to the negative 1/2. And that looks messy to me, so I could rewrite this as negative e to the positive 1/2. So I'm using some properties of exponents. You could also think of this as, negative e to, or excuse me, negative square root of e if you wanted to. All right, almost done. So now I'm going to take that, and I've got 1 plus c, but c is this. So I have negative e to the 1/2, and then I have this other e hanging out here. E to the negative 1 over x. And so if I use properties of exponents, remember when you multiply exponents, you really add the 2 plus the 3. 2 plus 3 equals x to the 5th. So we could write this as 1 minus is a constant, and then we have e to the 1/2 minus 1 over x. And that would be a legit answer for part B. Part C, again, kind of a follow-up question on some of this. So B's the one to focus our attention on, but let's just finish the job here. Part C says, for the particular solution, find the limit, or the infinite limit, as x approaches infinity. So part C is saying, find the limit as x approaches infinity of this function that you just found. So 1 minus e to the 1/2 minus 1 over, and then that infinity we think of as going right here. And in calc, when we're working with limits, we've talked about how 1 over infinity is like 0, or it approaches 0. I was doing so good. Oh, no. So what happens here is we've got 1, the constant's along for the ride, minus e to the 1/2, minus 0. So that's 1 minus e to the 1/2, which is a legit answer, or 1 minus the square root of e. And that's going to be your limit and the answer to number C. Letter C. So focus on that part B, though. Differential equation, I think, is going to show up. So thanks for watching.